All right, we're on section 14.3. This is about limiting reactant, or a lot of times it's called limiting reagent. So either of those terms means the same thing. Here's the objectives. Be able to explain what's meant by those terms, by the term a limiting reactant and excess reactant, and be able to determine it, and also be able to calculate quantities of products. Once you've determined that, determine what the products are going to be when you're done. All right, so first of all, let's talk about what is it. The limiting reactant is the one that's used up first in the reaction. So we're talking about like if you were trying to put bottle caps on bottles and you had 10 bottles but only 5 caps, meaning you only cap 5 of those. So the caps were the ones that were, in that case, the limiting reactant. If we're talking about an excess, that would be in my example, it would have been the bottles because that's the one that's left over when you're done. Okay, so let's get to work here. Let's see if we've got 34 grams of ammonia and 36.5 grams of HCl. We want to determine the limiting reactant. So first thing we need to do is to write the balanced equation. So let's go ahead and do that. Okay, so you can see the balanced equation here. NH3 plus HCl yields NH4Cl, and I've got 34 grams of ammonia. I've got 36.5 grams of hydrochloric acid. So what we need to do, you can see that everything is 1-to-1 in this particular example. So we need to figure out how many moles do we have, because grams don't really matter. Even though you would look at, say 34 smaller, yeah, but it's all about the mole. So let's figure out how many moles we have. So for NH3, we've got 34 grams of NH3. Each mole of NH3 is 17 grams, 14 plus 3 times 1. So 1 mole, 17 grams NH3. Therefore, we have 2 moles. Okay, so in terms of moles, that's what really counts here, 2 moles. If we look at HCl, we've got 36.5 grams. The molar mass of HCl is 1 plus 35.5, or 36.5 over 1 mole. So we get 1 mole of HCl. Alright, so once we have this converted to moles, then we can figure out which one's going to run out first. And we can see, since they're used at the same ratio, that our hydrochloric acid, or HCl, is going to run out first. Alright, let's take a look at another example. It says 72 grams of water react with 190 grams of TiCl4. And notice in this one now, we don't have the same, so we've got, or don't have the same coefficient. So we've got a 1 in front of the TiCl4 and a 2 in front of the H2O. Okay? So, once again, and what I like to do just to kind of help me out is I like to put my numbers down here. So we've got 72 grams of water. We've got 190 grams of TiCl4. And really, those numbers don't really tell you a whole lot until you convert all that stuff to moles. So the first thing, let's do the water. If we convert that to moles, 1 mole water is 18 grams. That would go in 4 times. So we have 4 moles of water. And if we do the TiCl, 190 grams, TiCl4. So Ti is titanium, which is number 22, and that's 47.9 plus 4 times Cl, which each one of those is 35.5. Going to make that look more like parentheses. So that equals, that's 189.9. Or we could say 190. Okay, so if we do that, 1 mole over 190 grams, and we see that that ends up giving me 1 mole. Now, there's a little more to it now because the coefficients aren't the same. What we need to do, every mole of TiCl4 takes 2 moles of H2O. And so what we really need to do, there's one more step. We need to divide these by those coefficients. So we're going to divide that by 2. Gives me 2. We're going to divide this by 1. Gives me 1. Okay. Now, whichever one of those is the smallest, in this case, TiCl4, that is our limiting reactant. Okay, so let's go through the steps here. Write out the balanced equation. That's always the first step. Second thing, convert all of your things to moles. Convert all your reactants to moles. And then last, divide by the number of moles, or in other words, divide by the coefficients in each one. And whatever gives you the lowest, that's your limiting reagent. 3 steps. 1, write out the equation. 2, change to moles. 3, divide by the coefficients will give you the limiting reactant. All right, let's try this example. This is yours. A student mixed 5 grams of carbon with 23 grams of iron 3 oxide. And what is the limiting reactant? What is the excess reactant? To kind of help you out, let's walk through this equation and then you can kind of work on it. We've got some iron oxide, Fe2O3. We've got carbon, and this ends up being a single replacement reaction. We would get carbon dioxide and iron is what we get for our products in this particular example. If we want to now balance that, it ends up being 2, 3, what do we got? 3, 4. All right, so use that, and now see if you can calculate this. So stop the video and try this problem. So we got 23 grams of Fe2O3, 5 grams of carbon. The molar mass of Fe2O3 is 159.6. So if we want to figure out how many moles of that we have, we've got 23 grams times 1 mole over 159.6, which we would get 23 divided by 159.6, 0.144. 144. Okay, so 0.144 moles. And if we do carbon, carbon is 12, so it's going to be 5 times 1 mole over 12. 5 divided by 12 gives me 0.42. So 0.42. Now, the last step was to divide each of those by the coefficient. So if we take 42 divided by 3, I get 0.14. If I take 0.14 divided by 2, I get 0.072. So now we look at which one of those is the smallest one. Well, that would be that. So, limiting reactant, excess reactant would be carbon. Okay? Well, we're not quite finished yet. Once we've figured out what the limiting reactant is, we still need to figure out our product. So we got to figure out using the limiting reactant. So we can't use the one that's going to have extra. You know, we wouldn't have enough of the other one. So figuring that out, we have to figure out what the product is. So let's go back to this example that we did. 5 grams of carbon, 23 grams iron oxide. Here's my equation. We knew that Fe2O3 was the limiting reactant. We are now going to start the problem using the data that we had. So we started with 23 grams, but we already calculated moles, so we can actually start there because that's a step farther ahead. And we're trying to figure out how many grams of iron would we get, and we can start with 0.144 moles of Fe2O3. We now need the mole ratios, the coefficients, so 4 moles of Fe to 2 moles of Fe2O3, so those cancel. if I want to convert that to grams, now 1 mole Fe 55, sorry, 55.8. 55.8. And then I just do the math. 144 times 4 over 2, or I could just say 144 times 2 times 55.8, and I get 0.144 times 2 times 55.8, 16.1 grams. So that's how much my product would be. So you can be given two different things. One of them is going to run out first. You got to figure out which one that is. Then you figure out how much product you're going to get. So several steps in here that need to be taken care of. All right, here's your turn. Try this one. 12.8 grams of ammonia and 14.5 grams of oxygen are allowed to react. How many grams of nitrogen monoxide are formed? And just so you know, the other product is water. So I want you to see if you can write that equation and then work on that problem. Alright, so if getting that equation was a little problem here's the equation. You can once again stop the video and do this problem yourself here. Alright, so you can see my calculations here. 12.8 grams NH3 divided by the molar mass, 17, gives me 0.75. For oxygen, 14.5 divided by 32 gives me 0.45. So let's put those up here. Moles, 0.75 moles. Now to figure out which one's the limiting reagent or limiting reactant, divide by the coefficients. Divide that by 5, divide that by 4. Okay, so 0.75 divided by 4 gives me 0.185, 1875, and 0.45 divided by 5 gives me 0.09. Okay, so you can see that the smallest one is this one right here. Okay, so our goal is to figure out how much of that is formed. We know we're going to use the oxygen, and we can start at the middle step. So we can start with 0.45 moles of O2. We're trying to find grams of NO. So I can first do mole ratios, 5 and 4. So 5 moles O2, 4. What happened here? 4 moles of NO. And then the last is to convert back to grams. So 1 mole NO. Let's see, 14 and 16 would be 30 grams NO. Okay, so 0.45 times 4 divided by 5 times 30. And I get 10.8. So, final answer, 10.8 grams NO. Okay, there you have it.